Bonjour. Hello, everybody. Welcome to what is probably the unhippest, uncoolest talk of the entire conference because it's about monoliths. Oh, even if you use JHipster, monoliths are still not cool. You must have seen lots of stuff in the industry at the moment. You know, it's all this battle between monolithic applications versus microservices, and microservices are cool and trendy, and they'll fix all of your problems. You know, what's a monolith? A monolith is basically bundling up all of your functionality to one thing, deploying one thing. And that's great. It's easy to do. We have great tooling to support this. You want to make one single line of code change, you have to redeploy the whole thing. Microservices, on the other hand, you know, you chop your application, your system up into lots of smaller parts. They all collaborate. They all interact. You can use lots of different languages and technologies and frameworks, and it gives you lots of agility. The downside is, of course, deployment overhead, operational overhead, monitoring management, and so on and so forth. And they're extremes. And of course, the hidden assumption in all of this is that monoliths are evil, right? They're horrible, big balls of mud, and we don't want to touch those things. That's the old-fashioned way of doing things, and we should move to this microservices thing because it's all cool. Right, so that's what we're going to try and fix in this talk. As you notice from my accent, I'm British. I'm actually from Jersey in the Channel Islands. Can you see Jersey on this map? It's kind of small. If this was one of those new iPad Pros, we could pinch to zoom in, get a bit closer. We could pinch to zoom in one more. There you go, there's Jersey. So it's a small island, 9 miles by 5. If we go back to this map, it's actually 200 miles from Paris. Right, I can see France from my house. Do you know how long it took me to get here yesterday? 10 hours. Seriously, 10 hours door to door because I cannot fly direct to France anymore. I had to go through London, change airports in London, and then come back down again. It's absolutely ridiculous. Why on earth do I subject myself to this? Because Jersey's a nice place, especially in the summer. Most of my career is spent working in London for consulting companies building Java systems. Over the past few years, I've been jetting around the world and really helping teams understand what software architecture is all about. And from my point of view, architecture needs to be much more accessible to all of us as developers. Yeah, there are lots and lots of books out there, but when I was moving into my first architecture role, I didn't really understand what to do. How am I solving this? I'm basically naively just writing some different books, writing some books that essentially distill the essence of software architecture. I'm also the creator and founder of this tool called Structurizer. And Structurizer is it's a software architecture diagrams as a service. Sad ass, unfortunately. And basically, it's a way to create software architecture diagrams using snippets of code. So you write some code rather than using Visio. And if you're wondering why on earth would you do that, it's because once you start writing code, you can do things like write code to do static analysis on a code base. So what you can actually do, and all of these libraries are open source, is you can write some code to extract architectural concepts out of your code base. And we'll see where that comes into play later. So I'm really interested in communication of architectures and also the design thinking that goes into creating good, well-structured systems. So let's imagine you come to me and you say, Simon, we'd like you to draw us a picture of our software. And let's say you have 1 million lines of C# code or Java code or something like this. And let's say that 1 million lines of code is broken up into 50 or 100,000 separate classes. If this was a whiteboard, would I draw you a diagram with 100,000 boxes on one per class? No. That's not a very effective way to describe what your software system looks like. So what we do is we use abstractions. And instead of drawing these 100,000 small classes, I'm going to draw you a smaller number of bigger boxes, representing things in your system, in your code base. We call these things modules, components, services, layers, and so on and so forth. And abstractions are basically a way to reduce the cognitive load. So they allow us to think about, describe, and reason about a large or complex code base. And that's all good, but of course the abstractions that we use to describe our software need to reflect the code. If I talk about a module or a component, I need to find that thing in the code somewhere. To make matters worse, because sometimes that's not the case, and we'll see shortly, we don't have a very good vocabulary to actually describe certainly the static structure of a software system. If I use the word component, what am I referring to? You know, for some people, a component is like the web application is a component of the bigger system. And for other people, a component is something running inside that web application. So we have a tendency to use the same terminology to refer to different levels of detail, different levels of abstraction in our code. So let's fix that first. How do I do this? For me, very simply, a software system is made up of a number of containers. A container is simply something that you run, you execute it, and it runs code or stores data for you. So in real terms, this is something like a web application, a mobile app on your phone, a standalone application, a database, a file system. If you look inside those containers, for me anyway, they are made up of components. So I'm going to use the term components to mean something running inside a process, inside a container. And because I mostly deal with Java and C#, my components are simply made up of classes. And that's it. It's just a really, really simple hierarchical structure that we can use to describe software. If you're doing JavaScript, this doesn't work, so maybe it's not components and classes, maybe it's modules and functions or modules and objects. So you can still apply this hierarchical approach to different languages by changing some of these levels. With these levels in mind, what you can then draw is some diagrams at each level in turn. And this is what I often refer to as my C4 model. So I'll draw a system context diagram, a containers diagram, a components diagram, and then I might draw some class or code level diagrams if I want the lower levels of information. We're going to skip this a bit. If you want to know more about this, I'm actually back in Paris in about 2 weeks doing a workshop. So these diagrams are essentially maps. What I'm trying to do here is create a set of diagrams that are maps on top of my software system. So much like with my introduction, you know, if you do a search for Jersey on your smartphone, you'll get this bottom picture by default. So Google Maps will zoom straight into Jersey and it will fill the screen. And this is fantastic if you want to know what's inside Jersey and what the place names are. If you've never heard of Jersey, it's totally useless. And the first thing you do is you zoom out. The diagram's the same sort of thing. Sometimes as a developer, I want the zoomed in view of the world. And at other times, especially if I'm speaking to non-technical people, I want to be able to zoom out. To give you a really quick example, when I moved back to Jersey, I built this site called techtribes.je, and it's just a really simple, super basic content aggregator for the local tech industry. It lists people, blog posts, and so on. So this is a context diagram for my TechTribes system. The box in the middle is my system. That's the thing I built. There are various types of users. We can, represent users as roles or actors or personas, entirely up to you. And these are my key system dependencies at the bottom. So TechTribes is pulling information from Twitter, from GitHub, and we're subscribing to people's blogs. If this diagram was interactive, we could select the monkey and pinch to zoom in, and we get to level 2. And this is the container diagram for the TechTribes system. And all it says very simply is that there's a web application. That's the point of access for all the users. There's a standalone process at the bottom. That's the thing that reaches out and connects to Twitter, GitHub, blogs. And all the data is being stored somewhere in the middle. This diagram doesn't tell you anything about failover, clustering, sharding. That's something we save for deployment view. So again, this is just static structure. If this was interactive, we pinch to zoom in on something we're interested in. We drop down to level 3. And this diagram shows you the components inside that standalone content update process. A bunch of connectors, scheduled tasks, and some other components that store stuff in the data stores. Again, if this is interactive, we could take this tweets component. All this tweet component does is it allows you to store tweets into a Mongo data store and retrieve them out again. We pinch to zoom in, we look inside that tweets component, and we get a class diagram. And this is where the model starts to unravel very rapidly, because on my previous diagram, I said there was a single tweet component. When we now look at what the code looks like, there's no such thing as a tweet component anymore. There's a tweet service interface, and there's a default tweet service implementation. I'm using Spring and Java, can you tell? And there's a tweet data access objects and a Mongo implementation. And this kind of raises the question, well, where did that tweets component disappear? where's it gone? The tweak component does not exist in the code. I said it did, but I lied to you. And really, the tweak component is a conceptual combination of all of that stuff. This is how a lot of people are still building applications. It's a traditional layered architecture. We have a services layer with businessy stuff, and we have a data access or some sort of repository layer. And at this point, somebody normally says, well, your component still conceptually exists. It's a combination of these classes and interfaces across your layered architecture. But it's not the same thing, is it? The code's not really reflecting that there is a tweak component. So does the code reflect the abstractions? In this case, the answer is no, because they're different. This is not a new problem. There's a great architecture book by a friend of mine, George Fairbanks, called Just Enough Software Architecture. And in his book, he calls this the model code gap. So when we're having an architecture discussion, we will use abstractions. Modules, components, layers, services. We'll use these abstract concepts to describe our software. But when we look at the code, these things don't exist. So quick show of hands, who's a Java developer here? Right, that's most of you. So in Java, is there a component keyword? No. In Java, is there a layer keyword? No. But when we're having an architecture discussion, we often use terms like component and layer. But when we're writing our Java code, we have to create these concepts with interfaces, classes, packages, for example. You can trace this problem right back to 20, 30 years ago. There's a great paper that describes this exact same thing. So if you grab a software engineer and you tell them to draw a whiteboard diagram of their system, you'll get a bunch of high-level boxes and lines. If you reverse engineer a diagram from the code, you'll get a totally different picture. The reverse engineered diagram, of course, is super accurate, but the reverse engineered diagram doesn't reflect the abstractions that the engineer thinks about. Like the mental models are very different. And it's often because we think in terms of components, but we're writing classes, certainly with Java and C# anyway. And again, this brings us back to our traditional layered architecture. So imagine we're building a really boring web application. A typical way to do that is to adopt the layered architecture. We have a presentation layer with controllers and view models and all that stuff. We have a services layer with some business logic. And maybe we have a data access layer with our data access objects, repositories, whatever you want to call them. Why do we do this? Well, we're told to. If you go and look at any introduction to Java programming, web app programming, Spring programming book, it'll basically say do stuff like this. So this is a picture I stole from a Spring book. It's a layered architecture. You turn the page, it tells you why. Separation of concerns, modularity, blah, blah, blah. You download some sample projects, it gives you a skeleton starting point. It says here's a folder for controllers and here's one for data access objects. You go on to Stack Overflow and you say, how do I organize my code? And somebody goes, there's a Maven archetype you can use. And again, it's all pushing you towards adopting this kind of layered architecture. Exactly the same in the .NET world with C# and ASP.NET. All right, so we're being pushed to use these layered architectures. A lot of this comes back to separation of concerns. So one of the good things about layered architectures is separation of concerns. So if I'm writing some data access code, I don't need to care about who's using my data and why. I don't need to bother myself with user interface concerns and all the rest of it. The vice versa, if I'm working on the UI, I don't care where my data comes from. I just know that there's an interface and I can call it. The problem is when we do this sort of thing in Java especially, we end up making each of our layers a separate package. And in order for one class in one package to call another class in another package, we have to start making all of these things publicly accessible. That's people's default way of doing this. And the problem is making all of your classes publicly accessible gives you a whole bunch of options. So here we have 3 nice, neat, isolated feature sets. And then somebody brings you a change request and they say, Simon, we would like feature set C to also show some data from B. How do we do that? You choose, right? It's entirely up to you. Do you call the service? Does the controller call the data access object? Right, there are lots and lots of different options you could use here, and if you don't apply enough discipline, this is why your nice layered architecture turns into a horrible big ball of mud. So a lot of this does come back to discipline. You might say, well, the layer thing's totally old-fashioned. We're doing onions and hexagons and clean architectures and ports and adapters. Well, guess what? They're just layered architectures as well, drawn in a slightly different way with some arrows going the other way. You can still make a mess with these styles of architectures as well. So should we be considering layers as harmful and evil? Well, I think that's a bit strong. But one thing to note about layered architectures in the software world is that our layers are not the same as other people's layers. There's a great talk by Ralph here, which you can go find on YouTube, and he discusses the difference between layers in software and the OSI network layer model. In the OSI model, the physical layer at the bottom and the application layer at the top are connected. And as you go up through the layers, they become more abstract. In a typical web application, the UI is not just a different abstraction on top of the data, it's something totally different, and that's his whole point here. I'm sure you've heard of cargo culting. There's a whole interesting story behind cargo culting, what it means. It's doing stuff because we think we should, but we don't really know why. And I think a lot of people are adopting a layered architecture because that's just the thing we do. And we're not really giving it much thought. And there are some other options about how we can organize our code, for example. So here's a slightly different question. Are these layers actually important? So are these layers structurally significant things, or actually are they just an implementation detail of something else? So that's a more interesting question to explore. Uncle Bob Martin wrote a great blog post a while back called Screaming Architecture. And he basically said if you look at a set of blueprints for like a library, it screams, this is a library. Right? You can tell by the drawings that this is a library. And you can see how people navigate and move around and use the library space. If you look at most enterprise code bases, they all look exactly the same. Controllers, service stuff, data access stuff. Maybe you might see some references to Spring and Hibernate, for example, in the folder structure. So code bases should scream something about what they are, especially related to, say, the business domain, the business concept. Martin Fowler published a blog post last summer, and he talks about this layering thing as well. And he says this is a very prevalent pattern. It's also a very useful pattern, because separation concerns and so on and so forth. But there's something really interesting in this article. He basically says this works for small-scale systems. Once your system starts to grow in size and complexity, your layers get very, very bloated. And he says maybe you need to stop doing the layering thing and apply another level of modularization. So again, he's basically saying layers might not be the primary way we should structure and organize our code base. So of course, there are some other options. One other option is this. It's typically called package by feature. It's like a vertical slicing approach. So rather than having a horizontal layer, all of your data access objects in one place, all of your services in another, this is slicing it the other way. Does this solve the problem of creating messy code bases? No, because if you add feature set C and it needs bits of B, you need to start making more stuff public. George Fairbanks, in his book, I'm going to go back to his book again, he says one way to fix all of this stuff is to use an architecturally evident coding style. An architecturally evident coding style is very simply making your code somehow reflect your architectural intent. So if I'm describing my system as being made up of a bunch of components, let's make sure that the code reflects that strategy as well. How do we do this in the real world? Well, actually, there are lots and lots of different options here. Some very, very simple options are things like naming conventions. if I have a tweet component in my, or on my architecture diagram, there should be something in my code with the same name, tweet component. Right, so we can apply a very, very simple naming strategy here. Maybe it's about namespacing or packaging. Maybe we use C#'s namespace or Java's packaging mechanism to bundle up all of the classes and interfaces that are related to a single thing, whether that's a layer or a module or a component or a service. Java 9, of course, is getting module support, which is another architecturally evident coding style, because now we can start thinking of things as being modules with module boundaries, and we can export specific things that are used by the public interface only. JavaScript is a bit of a mess, but again, there are lots of module patterns and things like this, and ECMAScript 6 is getting module support. Microservices. Microservices is actually an architectural evident coding style. Anybody doing microservices here? Right, a few of you. So if I were to drag you to the front and say, here's a whiteboard, draw me a diagram of your microservices architecture, I'm pretty confident that what you would draw would be one box per service with a bunch of lines between them. And I'm also fairly sure that I can take one of these boxes and find it in your code very easily. So there's a nice one-to-one mapping between what we see on a diagram or what we find in the code. What I tried to do is what I call package by component. So what I'm going to do here is I'm going to take advantage of Java's packaging mechanism, and specifically the access modifiers, and I'm going to bundle together classes that should live together. So I'm going to stop doing these services and repositories split, for example, and I'm going to stick those two things together, wrap them up. And this is really, really simple, trivial refactoring most of the time. So this is the picture I showed you before. This is what my tweet component looked like. And the refactoring is very, very simple. So I've taken this tweet service interface, and that's now been renamed to be tweet component, no changes. This default tweet service, which is horribly named, is now called tweet component impl, which is also horribly named. But what I've done is I've made it package protected, right? So it can't be seen from outside that package now. The interface, I've killed it. And I've taken this MongoDB tweet.io and put it over here. Again, made it package protected. And actually what I've done is I've hardwired these two things together because they're just an implementation detail. So it's a really, really simple refactoring. Now if somebody wants to use or get access to my list of tweets, they must go through this one interface. They can't go through that because it doesn't exist anymore. When some people see this, they get a bit freaked out because they're like, well, we had a nice layered architecture before. Where's your layered architecture gone now? And the answer is it's inside the component. So if we treat this package as the component boundary, my layers are now an internal implementation detail. I can still switch out Mongo to some other database just by changing that one class in one place. So I still have some of the benefits of, isolating things that change together, but I'm taking a more holistic view of my architecture. This is what the code looks like. All of this code is open source. You can have a look at it. Basically, I create a component package, and then I have a separate package per component with all of the implementation classes sitting in there. This example uses Spring, so I also put my component configuration in the same package. The keen-eyed will have seen there's an @component interface here. That's not the Spring @component interface. That's my own custom annotation. And because I now have this nice architectural evident coding style, I can use some tooling to go and find these things and create diagrams automatically. And that's exactly what the structurizer tooling does. It allows you to generate diagrams essentially for free. So now when we go back to our diagram, then this is the component diagram for the standalone process. We select the tweet component, we pinch to zoom in, hooray, we got a single box. So now I can say to one of my developers, go and modify the tweets component, and it's all sitting in a single place. It's not a bunch of classes scattered across a layered architecture. And really what I'm trying to do here is I'm trying to reintroduce modularity as a way I design software. Right? Modularity is an overriding principle here. Ironically, this is exactly what microservices does. So with a microservices style of architecture, what most people do is they'll create a bunch of services, a bunch of microservices, and maybe they'll have all the code in one place, or maybe they'll break it up into a little internally layered architecture. let's take that same approach and apply it to our monolithic systems. So let's take some of the microservice design thinking and apply it to our monoliths. That's all I'm doing here. Of course, in a microservices world, you can't get into these classes because they're behind a remotable API. But again, we can still use things like Java 9 modules or even Java's access modifiers to restrict access to, this class from the outside world. In order to do this, it turns out you need to make some design decisions. And this comes back to asking yourself, how do you design software? And specifically, how do you take a problem and decompose it into a bunch of things, modules, components, or services? So what's your decomposition strategy? There's no single answer to this, of course. If you go look up decomposition on Wikipedia, it says, it basically tells you what decomposition is all about. It's breaking something up into smaller chunks. And it says there are lots of ways we can do it. OO, modules, components, whatever. You can take this right back to 1972, I think, and David Parnas's classic paper about modularity and decomposition. And he takes an example program and he says, here are two options for how to split up this application into different types of modules. And these are the benefits of taking each of these different strategies. And again, all of this stuff should be a conscious decision. It's exactly what we would do with a microservices architecture. We would put some thought into figuring out how to split up and create a bunch of different services. But somehow, when I see teams building monolithic systems, they don't apply that same level of thought. They just start with a layered architecture. Of course, you have all of these components, these modules. You have to figure out how they interact. If we were building a microservices style of architecture, we have a whole bunch of options. Synchronous, asynchronous, events, commands, messages. The same applies to components running in a monolithic system. Just because you have all of your components running in a single process, they can still talk asynchronously. Where do you put your domain classes? Do you put your domain classes next to the components, or do you have a separate bag, a separate package with all of your domain classes in? Right, that's a decision you need to think about. Stuff like shared code, utility code. If you look at my Tech Tribes example, all of my components inherit from an abstract component-based class. Well, where do I put that? Well, my answer is just dump it somewhere in a utils package. It doesn't really matter. Same thing with data storage. Just because we're building a monolithic system doesn't mean we need to have a single monolithic database schema with full referential integrity. We can still do the whole polyglot persistence thing with components in a monolith. And again, these are design decisions that you need to make consciously. And that's the thing here, right? These are design decisions and they should be made consciously. In other words, they should be made for a reason. Something else I want to talk about briefly is testing. Because there's an implication to testing in all of this. Anybody read this? It's fantastic. It's super controversial, so a paper from Jim Kaplan, Why Most Unit Testing is Waste. This was published a few years ago. If you've not read it, I definitely recommend seeking it out. I absolutely guarantee you won't agree with most of it. But there's some really, really interesting nuggets and snippets in here. And one of them is essentially this. So if you look at things like unit testing, imagine we're building something that talks to a database. We have a services layer and a repository layer. One of the typical things we've always done is in order to test our service layer quickly, we provide a mock implementation of our data access layer. And this is because, 10, 12, 15 years ago, databases were slow. Hardware was slow. So introducing this new mock database object thing could speed up our tests. It's 2016 now. This Mac is awesome. It's got ½ terabyte of flash storage or something ridiculous, 16 gig of RAM. It's fast. We have Docker, we have Vagrant. I can spin up a database environment super quickly. So some of these older arguments are no longer valid. When that article came out, there was lots of controversy in the industry, and the Rails guy, DHH, jumped on this and said, actually, yes. Sometimes you see code bases that are made up of millions and millions of really small parts all interacting. And that's because the testing strategy has forced the system and the code base to be broken up into lots of small parts. Again, so we can mock and substitute and have fast-running unit tests. And he's basically saying sometimes that wrecks and ruins the cleanliness of the design. If we go back to my refactored tweak component thing, traditionally, how would we test this? Well, what I would typically do is I'd want to test this in isolation, so I would provide a mock tweet data access object. It runs in memory, produces me some canned results, which means I can write tests really fast just against that and isolate myself from the database. How do I do that in my new refactored world? As I said before, I've actually hard-coded this MongoDB implementation into the tweet service implementation. I can't split it out. So I can't mock out this thing down here very easily. So how do I unit test this thing in isolation? And the answer is, just don't do unit testing. And that's exactly what I do. I don't do any unit testing on this thing at all. Now, that's not to say I don't test it. And I've already spoken about cargo culting, and I'm wondering whether we apply the same sort of mindset to unit testing as well, or specifically automated testing, because that's what we've been traditionally taught to do. Write some code, write some small unit tests that run very, very, very fast, we get fast feedback, blah, blah, blah. And we have this testing pyramid triangle thing, which says, as normally good starting advice, make sure you have a large number of very, very fast-running unit tests. I have no idea what the word unit means, but that's what we should do. Right, next time you're back in the office, ask your colleagues what a unit is. If you have 10 colleagues, you'll get 10 answers. Is it a class or method or a unit of behavior or functionality? I have no idea, because everybody has a different idea of what a unit means. And then typically you'll have some slower-running integration tests. These things normally break. They're always @ignored. They're very slow. And if you're really lucky, you have some system-level tests, UI functional acceptance tests on top. And that seems like good advice. But again, if we go back to this whole modularity thing, and let's say I have a component now, which is made up of a couple of classes, a service and a repository, we have options. Typically, what we would do is we would write an isolated unit test for this and provide a mock repository. That's a unit test. If we want to test the database code, normally we would spin up a database and we would write some sort of integration test that tested this. The other option here is we just treat this whole box as a component and we do a component level test of the whole thing at once. So what I'm saying here, what I'm suggesting, do you think about at least, is instead of blindly unit testing everything in isolation at the small level, why don't we start testing some of our bigger building blocks as black boxes? Right, so if we see our system as being made up of services or components, why don't we have service or component tests? Caveat time, right? This approach does not work for everything, and this is what I said about conscious decisions. So if I'm building a component and it talks to a database that I own, and I can spin up the entire stack, that's great, it works beautifully. If I'm building a component that talks to a third-party system out there on the internet that I can't control, if I'm building a component that sends a message on some sort of message queue, there's some asynchronous behavior, well, then I need to go back to actually providing interfaces and mocking out certain parts of the implementation. So there's not a single approach to any of this. Some components respond really well to component testing through the public interface, others not so much. And again, testing is a conscious decision we need to make. I refer to this as architecture-aligned testing. So one of the things I really want to do is get us away from using these silly terms, unit and integration. So what I want to do is I want to have a bunch of fast-running class-level tests. That's essentially what they're doing. They're testing a single class in isolation, mocking out other parts around it. I'm going to have a bunch of slightly slow-running component tests that test my components through the public interface. And hopefully I'm going to have some system-level tests at the top. And you'll notice the terms I've used here go back to that hierarchy I gave you right at the start. It's the systems, containers, components, classes. And ultimately, my goal here, and please don't take this quote out of context because I absolutely guarantee somebody will, what I want to do is I want to get as much test coverage as I possibly can from the minimum amount of test code. And of course, there are extremes here. On the one hand, we could write millions of small unit tests. And on the other hand, if I'm really lucky, I can write one gigantic, monstrous acceptance test that runs through the entire system. Right? That's a really bad idea. And I think testing everything in isolation is also a really bad idea. So I think there's a sweet spot to be explored here somewhere, and that's going to vary depending on how you structured your system. Essentially, what I'm saying is this. There's a really, or there should be a much tighter integration between how we think about the architecture of a system, how the code is structured, and how we test that code. So the tests reflect the code, the tests reflect the architecture, the code reflects the architecture. All of these things should be linked, in my view. Why did I put this talk together? Well, it all comes back to maintainability at the end of the day. Some systems are really nice to work with, others not so much. And for me, what I normally see is maintainability has some sort of inversely proportional relationship to the amount of dependencies you have, or the amount of public stuff you have, or maybe the amount of microservices you have. And what I'm looking to do here is build a really easy to maintain system. A good architecture actually gives you agility. So again, that's something to think about here. If you want to be able to move fast, if you want to be able to respond to changes in requirements or the environment, you need a good architecture that gives you agility. You need an agile architecture. Agility, right, the speed that you want to change direction and move is actually a non-functional requirement. Some organizations, some teams, some systems don't require huge amounts of agility because you're living in a fairly static domain. And others, like in the startup world, you need a very, very agile architecture that you can change and flex very, very quickly and easily. And of course, it's that you should take into this question. So what style of architecture should I build? Should I build a monolith or a microservices architecture? Well, how much agility do you need? And how much are you willing to pay for that benefit? And of course, we always talk about extremes, but there is something in the middle. We can build a well-structured modular monolith, which gives you, the benefits of both of these worlds combined. And for me, really, building a modular monolith with components is a really, really nice, simple stepping stone towards a microservices architecture. Essentially, we have a bunch of really nice, neat in-process components here. If we think about modularity and component boundaries and encapsulation, that gives us a bunch of benefits. Especially reduces the amount of static dependencies between our components in our code base. If you want the ability to build components in different languages, if you want the ability to version components, if you want the ability to scale different parts of your system, that's when you get the benefits of doing microservices. And if you have a nice bunch of neat component boundaries, it's really, really easy to carve those things out and put a network stack around them and turn them into essentially a microservice. So my kind of closing advice here is really choose microservices if they give you benefits. It's not an architectural style that suits all of us. And if you can't build a well-structured monolith, don't do microservices at all. Because if your monolithic code base is a big ball of mud, you're just going to get a distributed big ball of mud. Right, sticking networks in the way is not a good idea if you can't create a nice modular monolithic code base. If your software system's hard to work with, it's your responsibility to change it. And that's where you can take some of the layered architecture stuff and maybe start wrapping it up, creating a more modular system. Closing advice. Think about how to line all of these worlds I talked about, specifically the software architecture world and the code world. If you talk about your system in terms of components, make sure you can find those components in your code base. Make sure they're easy to identify. Be conscious of that software architecture model, right? And try and adopt the architecturally evident coding styles. That's a really, really simple way to do this. Even things like naming conventions can help hugely. What advice can I give you to take away, today, right now? Stop making all your classes public. That's a really, really simple piece of advice, yeah. Because it's something we do all the time. It's muscle memory, though. Every time I open up a blank file, I guarantee I will type public class just without thinking. How do I stop that behavior? Well, I could chop your fingers off, but that's a bit harsh. The other thing you could do is charity donation. Every time you do this without thinking, charity donation. Well, that would also work to some degree. And finally, my closing comment is very, very simply this. If you can't build a modular monolith, please don't do microservices. Thank you very much. So according to the clock, we have 4 minutes and 6 seconds for questions. At the front here. So the question was, how does this align with domain-driven design? And I guess you've got the kind of strategic DDD and the tactical DDD. And when I see people doing DDD, they're normally doing these services repositories thing. And I guess what I would urge people to do is maybe to think about combining these things into bigger chunks. Yeah, yeah. And of course, that's another way to think about this. If you're doing design for microservices architecture, how do you figure out what your service boundaries are? And one way to do it is aggregate or bounded context, and it's the same with components in a monolith. Other questions, if we have them? The front. So the question is, have I tried CQRS? And the answer is yes, and I guess the follow-up is, how does it relate to this? It's exactly the same sort of thing. So if you're doing CQRS, you're going to have a bunch of components that implement that pattern. And again, it's just a matter of exposing those components and making sure that you've got things properly encapsulated. You know, so any architectural style or pattern you can still apply to this style of approach. Question next to you. Yeah. Yeah. So the question is, sometimes if you take this kind of component-based approach and you want to write bigger component tests through the whole component, often there are classes inside you realize that you still need to test in isolation. And the answer is that's fine. You know, you can still take a combination of approaches. So, you know, with some components I've got, particularly those that talk to external components in the outside world, or they're doing something asynchronous, sometimes I will write smaller class level tests to cover those things, but I still might have some component level tests on top as well. So again, you can still test a single component with multiple layers and multiple strategies. Did that answer your question, or did I answer a completely different question? Which is entirely possible. Yeah. So if I'm writing a component level test and my component depends on another component, I will often provide a simple mock implementation. So you know, you can apply mocking at different levels as well, and I don't think that's bad. Again, it's about making sure you're focusing on the thing you want to test. So if it's at the component level, then you mock out other components, for example. We have 14 seconds. At the back.
cloud. Because with microservice, you can scale by component work. How this can be handled with modularity?
So the question is, with a microservices environment, you can scale bits of it very easily on the cloud. How do you take that approach to a monolith? And the answer is, go look at Stack Overflow. And essentially, if you look at Stack Overflow, it's a monolith. And in order to scale it, they scale the whole thing. And that's the trade-off, isn't it? It's a simplicity versus, ability to scale out a single thing. And it's a conscious decision that you need to make. Yeah, right. Yeah. Well, costly, not so costly. It depends what you're trying to scale and how you're trying to scale it. But it's just a different approach to scalability. Neither's right, neither's wrong. We're done. Cool. Thank you very much again.